Hi friends, welcome to my YouTube channel. In the previous video, I have discussed about deployment, replica set and pods in Kubernetes. In this video, we'll see what is Kubernetes service and why Kubernetes service is needed. Also, we'll discuss different types of services in Kubernetes. Those are cluster IP, Nodeport and load balancer. Let me open a white space to explain more of these concepts. And there it goes. Okay, as I mentioned in my previous video, I have discussed about there is a deployment which in turn creating a replica set by using a replica controller in Kubernetes, and this replica set will maintain the count of the pods as per the replica attribute mentioned in the deployment YAML file. So this is what we have discussed so far. Now in this video we are talking about services and why services is introduced in Kubernetes. So when we did till deployment, here what is happening, this is not exposed to the outside world. If suppose there is a microservice in the pod which need to be exposed to the client, outside client, so client can't access this microservice. This is within the Kubernetes cluster itself. So how to expose this? To expose this, like if we give a pod IP address to the client and ask them to access, that is not possible because they don't have access to the cluster, and the pod IPs keep on changing. The pods are ephemeral in nature. That means they can come down and destroy at any time, and a new pod will be replaced as per the replica set in the deployment YAML file. So this is not a real time scenario where we can give clients to access our microservices which is running in our pods. So what services in Kubernetes tells, okay, service, I am the abstraction to the deployment, and what I will do, service, I will be having one static IP and followed by one arbitrary port which can be given to the client to access, and which in turn send traffics to the pod through deployment. What we have created a pods, so that traffic will be sent to pod, and this service will be having one IP followed by one arbitrary port which can be given to the client, and we can ask the client to expose, means it can be exposed to the client to the outside world, and they can access through the static IP which the service will be having. That's fine. And what all benefit does this service provides? So I mentioned in the notepad, service helps in three things. That is, first thing is service discovery, and it will helps in load balancing, and this helps in exposing our microservices which is running inside the pod to the external world. Coming to the first point, service discovery. What is service discovery? So as I mentioned, these pods earlier we have seen, right, the replica set, it will create a pods, and these pods, every pods will have its own IP addresses. So this pod is having a different IP address, and the other pod is having a different IP addresses. So if suppose this pod went down as per the replica set and the replica attribute in the YAML file, new pod will be generated, which is the feature of deployment, that is auto healing. So new pod will come up in place of the destroyed pod, but the new pod which has came up, this will be having a different IP address. So these IP addresses are not constant, they changes as the pod get destroyed and created a new pod. Hence, what service will tell, service in Kubernetes is telling, okay, I can't filter these pods, the microservices which are running inside these pods. I can't filter these pods at IP level, IP address of the pod, because the IP address of the pods are changing very frequently. So let me give labels to the pod. So what I am telling, let's give label to the pods, and then using those labels I will select those pods having the labels, targeted labels. So only those are getting filtered, and I will serve my service like incoming traffic to those pods which are having those specific labels which I have in my selector. Might be this is not clear, so let me as I mentioned, right, this is selectors and labels. So let me go to my GitHub page. So here I have my YAML files. I will share this link in my video description as well. So what is happening, this is the deployment YAML file. So if you see under the spec, we are having three replicas, and under the metadata of the pod, here we have introduced line number 15 labels, and we are giving pod three pods. They will be having the labels as app nginx. And in this cluster, as I told, there are sorry, in this service, as I told, there are three types of services which we will see in this video. The first one is, default one is cluster IP service. So if you see the YAML file of this one, here we are using the selectors. So labels we are using in the deployment at the pod level. If you go to the deployment, here we are telling label the pod with app nginx, and they use this label in the service YAML file as a selector. So we have to select those pods which are having labels app nginx. So we are filtering the pods with the help of labels, and we are not filtering the pods with the help of IP addresses, because the IP addresses are changing abruptly. So this first point is met, service discovery. So every time the service is getting access, the microservices is available to the client, because the pods what they are targeting is they are using the label concept, selectors and label concepts. Hence the service will be always be served to the client. They are not filtering with respect to the IP address. So first one is done. This we will see, like we will try to implement the cluster IP service, then we can go to the other points. So let me go to the play with Kubernetes online, and let me launch the cluster. Click on start, get the new instance. So this instance can be used as a control plane or a master node. Let me run this command to initialize the cluster. Control insert to copy and shift insert to paste. It will take some time. So meanwhile I will be launching one more node, that is called as data plane or a worker node, and I have to run command cube adm join command in node 2 to join to the cluster node 1. So which will be getting in this output of this executing command. Let's wait for few seconds. Okay, so this is the command cube adm join command, which will join our worker node to the cluster node. Control insert and then execute this command in node 2, shift insert run. So this node is added to our node 1 cluster, and to initiate the cluster networking we have to create some services. So we have to copy the second command, and we have to run in the cluster node. We have run, and these are the services created. Now let's see whether nodes are ready or not. Cube ctl get nodes Yeah, control plane and the data plane both are ready. Now we will create our deployment. So let's go to our GitHub page and the deployment file. Just copy the line here, whole whole lines of the deployment file, and let's go to the online Kubernetes where it is. Yeah, and let me create a file called deploy.yml and then paste the code here. Come out of the file. To deploy the deployment, kubectl apply -f deploy. It deploys our deployment. To check, run the command kubectl get deploy. Perfect. Our deployment is ready. To check the replica set, give the command kubectl get replica set. Short form is rs. Yeah, it is running. And to check the pod, kubectl get po, or we can give pods. Three pods are running. To check, to have know the IP address of the pods, give -o wide. So these are the IP address of the pods, which can change if I delete one of these pod. So as per the replica set controller, it will bring up a new pod which will be having a different IP address. So the labels and selectors comes into pictures for services to serve to the client continuously. Hence that part is called service discovery. So now deployment is fine. Now we will try to create service. So let's go to the cluster svc file in the GitHub directory. So this is under the specs section. I can give next line type as cluster IP, but if we don't give anything, by default it will create the service called cluster IP, and there will be one cluster IP by default when we create a Kubernetes cluster. To see that, run command kubectl get svc, or we can write services. So this is the default one. Kubernetes cluster IP is the default one which will be created while we are creating the Kubernetes cluster. So similarly, we are trying to create one more cluster IP, and the selector here is the label which we have mentioned at the pod, that will be selector. And under port sections there are protocol. This is the TCP protocol. And port, the port, this port is the my service port. This is the arbitrary port which is assigned to the service called my service. And target port is the container port. The container which is running inside our pod, that container port 80 is exposed. So let me copy this and let's create a cluster IP service service.yml. To implement this, kubectl apply -f service. Service is created. To check, kubectl get svc. So you can see there is one more cluster IP with, and the port is 8082. As you see in the YAML file, like for my service we have exposed an arbitrary port 8082. And the cluster IP, this IP cluster IP service is only accessible within the cluster IPs, and it is not exposed to the outside world. So to check that, let me run curl command from the node 2 curl, and let me copy that cluster IP, paste, and it is exposed to the port 8082. Yeah, we can see it is accessible within the cluster. So cluster IP service is accessible only within the cluster. So whoever having access to the Kubernetes cluster, only those can access this service called my service. Okay, now we'll move to the next one. So now we want to expose it to the outside world. And also one more thing, as I mentioned, services is helping us in load balancing as well. So let's see what is how it is helping in load balancing before going to the third point, that is exposing to the external world. So let's go to the cluster, and then we'll try to get the logs of, okay, we will hit it actually. Let's hit from here. We will try to access curl one time, two time, three time, four time, five, six. So I tried, I have hit it. So there are three pods actually. So let's try to see the logs of these pods. Kubectl logs, and the first pod name. Yeah, we can see there are few requests went to this pod when I hit the curl command. And let's see others. Let me, so it is a random one. So it is like, load balancing, and it sends as per the resources like that. So it is a random one. But yeah, if they have a lot of curl requests and other requests, right, it will do the load balancing. So let's see the logs for second. Yeah, I guess for third it has sent less request. Let's see. No, this is again a second one. Sorry, I have pasted second again. Okay, let me copy it. Second one, and then yeah. Okay, second is also having three requests. So let me check the third one. Yeah, third one is having so this is how it is doing the load balancing. So second point is also we have seen practically. Service is helping. First is service discovery, and it is helping to do a load balancing between the pods. Now to expose to the external world. So to expose to the external world, we have to see two here. Like the first one we already discussed, this service is accessible only within the Kubernetes cluster, and Nodeport, this service is nothing but, let me go to the white space and see, this is our node 2, right? So we have launched node 1 and node 2. Node 1 is our cluster, and this is our node 2. And if there is a pod running on this one, and inside this pod there is a container, correct? So this node port, what will do, it will expose one of the static port of this node here. So let's go to the node port YAML file. So here we are giving a type as node port, and selector is same, app nginx. Here I want to tell about the one more attribute introduced in node port, that is node port attribute. So this is the port of the machine, means it is the port of the worker node actually. So if you see this, the node 2 is a worker node. So at this, like, no, it has some range like 30,000, I guess. Yeah, 30,000. It starts from 30,000 and 32,767. This is the range of this node port. So we can use within this range, node port range, and this is the port getting exposed at the worker node. Basically, if you are using any clouds like EC2 machines and all, so those EC2s, the ports of those EC2s are getting exposed. And as I mentioned earlier as well, in the cluster ip um, YAML file as well, the target port is the port of the container. So if you come here, so this is the at is the at is the container port, target port is the container port, node port is the port of the worker node, and this port is the arbitrary port which is been assigned to our service, my service. Hope this is clear. And whoever like employees or the client, whoever within the organization only can access, like whoever have access to these worker nodes, those ec2s and all, or they which whoever is having access to the vpcs vpns of the organizations, only those employees or those clients can access this service. It is still not exposed to the outside world, it is exposed to the outside world, but within the restricted and network, that is like within the organization or within your vpn. So those things, so whoever is having access to these worker nodes, those can access this service. So let me try to create this service. I'll modify the same one and I'll override that. Let me implement this by running kubectl apply -f .yaml. Okay, it's created. Let's check. Yes. So now you can see the type is node port type and it is giving one cluster IP. There is still no external IP, as I told. It is within the organization or within the VPCs or within the VPN. But if you see the port section here, this 8082 and 30007, this is the 8082 is the arbitrary port of the service, and 30007 is the node port of the worker node. If you want to access, like I am using online, so I will not be able to show you through the browser and all. But yeah, if you in your organization, if you want to access this service, you can just hit in the browser the IP address here, the node to IP address 192.168.0.22 colon 30,007. So this is how you can access the service. And within the cluster, still you can do the same thing as we did for the cluster IP. So do the curl and then curl followed by the IP address and then whatever the port, so of which is like no arbitrary port of the service. Sorry, I haven't given curl. Yeah, this is how it is. So still this node port is acting internally. When it is acting, it is acting as a cluster IP within the cluster, and when we are trying to expose it, so this will be exposed only within your organization or within the VPCs or within the VPNs. Whoever is having access to those worker nodes, those can access, and those can be accessed from the IP address of the node followed by the node port. Hope this is clear. Now, okay, fine. Now this is exposed to some extent. So now if you want to expose it fully to the external world, then comes the third type, that is load balancer type. So load balancer type, it will like if this is only used when your cluster is in any of the cloud providers, then only this load balancer service type can be used. Otherwise we can't use this service. So if the cluster of our if our cluster is with our aws or microsoft azure or uh, in the gcp, like we are using their services, eks or aks or GKE. So if you are using these cloud provider services, then yeah, the load balance, when we create a service type called load balancer, it will send a message to the cloud provider using one of the component, as I told in my previous class as well, cloud controller manager. This is the component which talks to the cloud providers, and it gets the external IP from the cloud provider. With that IP, we can do the we can expose it to the outside world. I can't show it practically, but I can just create a load balancer service and show. So let me go to this file. Everything is same, only the type is different. So I'm keeping everything same. I can modify the existing file itself, but I just override that. Okay, let me apply it. It's applied. Let's see the services. So if you see the type, it became load balancer, and it is the this is the cluster IP. And if you see external IP, it is pending. So as I told, it will send a message to the cloud control manager, sends or communicates message to the cloud provider, and using their services like EKS, AKS, and GKE and all these services, it will get an external IP from there, and this external IP gets exposed to the outside world. Hope all the three services are clear. There are few more services which they use very rarely, and yeah, if you want to get more details of any other services, still we have head headless service and all. So yeah, if you want those details, let me know in the comment section. And if you have any doubt in any of the section of this video, please let me know with the timestamp so that I can come back to your queries. Thank you friends for watching.